kids, we got a little video here dealing with fractions in the order of operations. We're looking at how to apply the order of operations when you have more than one step in a problem involving fractions. So let's take a look at some of these here. We're just going to kind of do an overview, and then I'll do the problems one at a time and show you all the work. I'm really not even going to do a whole lot of editing, I don't think, on this video. I'm just going to let her rip and see how it goes. But I want you to take a look at problem A. All right, problem A has a combination of subtraction and multiplication, okay? Now, if you guys remember the order of operations, you'll remember you have to take care of multiplication and division before you do addition and subtraction. So the step we're going to be taking care of first when we do this problem is going to be 1/3 times 9/10. We're going to deal with that first, and then we'll worry about the subtraction. In this problem here, problem B, however, if you take a look, it's got parentheses. Now, you'll remember that before, in the order of operations, before you even get to multiplying, dividing, and subtracting, before you even worry about any of that, you got to worry about parentheses. So we would actually take care of this step first, okay? With these ones here, we've got some exponents built in. We're going to have to take care of that exponent. We're going to have to take care of that term. We're going to have to take care of that term. We're going to have to take care of that term. Then we can start worrying about simplifying it down and getting into adding and subtracting, all right? These ones are a little bit extra complicated, but I want you to have some examples to look at so that you know what to do with them if you encounter a problem like that. And plus, it'll be a good refresher on exponents in general. All right, let's take care of problem A. So the first thing we got to do is we got to do our multiplication, right? So we take care of any canceling that we have. And right here, we've got some canceling we can do with 9/3. So that would turn into 3/1. Okay. So now you're going to do the multiplication, 1 times 3 and 1 times 10. So that gives you 3/10. So we have now is we have 5/8 minus 3/10. Now remember, when you're adding and subtracting fractions, we've done this before, you've got to change these fractions to where they have common denominators, all right? So what's a good common denominator for 8 and 10? 40, you say? Absolutely, that is the lowest common denominator. So we turn these into 40ths. 8 times 5, excuse me, not 8 times 10. 8 times 5 would give you 40, so we'd have 5 times 5. So it's 25 40ths minus 12 40ths. You're wondering where I got that? 10 times 4 is 40, so 3 times 4 is 12. I don't want to write too much on this paper here. I don't want to make a mess of it, so we'll call it good with that. So we have 25 minus 12. Our answer is 13 40ths. Not terribly complicated. If you're having trouble with this, you can go ahead and you can back that up and watch it as many times as you need to. I don't really feel the need to write anything else down on the paper for this particular problem. I just think I would just make a mess of it if I did anything else. So I'm going to let it stand there. All right. Now we got to take a look at this problem here. I told you before, we got parentheses here. So we're going to take care of the parentheses. So we got to do that subtraction first. We got 9ths and 12ths. We got to have a common denominator for 9ths and 12ths. That would be 36. So we're going to turn this into 36th. So 9 times 4, so we got 7 times 4. That's 28. And then we have here 12 times 3, 1 times 3. That's 3. Now be careful when you're doing these problems. Don't forget to put your parentheses in there. I see kids do that a lot. They do a step, but they forget to write the parentheses down. Don't forget to do that. Really important to do that. So we got 28 36 minus 3 36, and that'd be 9/10. Excuse me, times 9/10. Excuse me, that wouldn't be 9/10. That's just silly. So 28 36 minus 3 36. That would give us 25 36 times 9/10. And then we do any canceling that we can do here. All right. Now, one thing you probably noticed that jumped out at you was the 25 and the 10, right? So we cancel out the 25 and the 10. 25/10, that would give you 5/2. And then, you may have seen this, you may have not, but I'm going to do it because it's there. 9/36. 9 goes into 36 4 times. So again, be careful Don't go, oh, 9 times 4 is 36, and write the 4 up here. That's not how that works. Remember, it's 936. That simplifies to 1/4. 9 divided by 9 is 1. 36 divided by 9 is 4. So then we just do our... very frustrating. Angry! 5 times 1 is 5. 4 times 2 is 8. So our answer is 5/8. Again, a little bit of work involved there. But if you just do the steps one at a time the way you know you're supposed to do them, these will work out. I'm just going to tell you, these problems here are actually a little bit more complicated even than the kinds of problems that you're going to see in the work packet. The ones in the work packet are actually going to be a little bit easier than this. But if you can do these, then you'll have no problem with the ones in the work packet. Okay? All right, let's go on to example C. So I got 5/7 plus 2 to the 3rd power over 3 squared plus 5. We got to take care of those exponents right off the bat, okay? So we got here, let's turn this into 5/7 plus, now 2 to the 3rd power, that's 8. And then 3 squared would be 9. So we got 9 plus 5, all right? So, let's see here. I don't have a whole lot of room to work with here. So, what I think I will do, I may have to, like, draw a little line and go kind of up around to the top again. So, let's take a look here. So, now we have 9 plus 5. Well, that's 14, right? So, we got 5/7 plus 8/14. Okay? So, we got 5/7 plus 8/14. So now we need common denominators. So 7 and 14, really simple problem. Turn this into 14. That's all you got to do. So we got here 10/14 plus 8/14. And that's going to equal, let's just put it down here, 18/14. Now, take a look at that. Why are you not just going to leave that problem like that? There's really only one big problem with it. There's two things you could do. There's only one thing I'm going to require you to do. What's the one thing I'm going to require you to do? Simplify it. And what can you divide 18 and 14 by? Twa. Absolutely. Twa. What's twa? 2. 18 divided by 2 is 9. 14 over 2 is 7. You're all set with that. Could you turn that into 1 2/7? Sure. Would I mark it wrong? No, absolutely not. Would I say anything about it? No, I wouldn't even mention it. You could totally turn that into 1 2/7. Do you have to? No, I don't think so. I think 9/7 is a perfectly acceptable number. When you're dealing with multiplying fractions, adding fractions, stuff like that, there's nothing wrong with that answer, 9/7 at all. But 1 2/7 is equally acceptable. It's entirely up to you. All right, last one, D. This one, again, not complicated. It just looks complicated. But it's if you just take the pieces one at a time, each individual step is really very simple. So if you just take each individual step one thing at a time, you're going to find this is pretty easy to do. So let's work this out. So we got here 5 squared, right? 5 squared, 25. That's easy. Then 6 squared minus 8. Well, 6 squared is 36 minus 8 times 21/30. So we've taken care of our exponents. Now let's simplify this down a little bit further. We got 36 minus 8. That's going to be, I'm trying to have 28. I'm doing that in my head, I believe. So we got here 25/28. I really hope that's right. Times 21/30. All right? So we got 25/28 times 21/30. Now just look. What we did was not complicated. 5 squared, 6 squared. Pretty easy to do those exponents, right? 5 times 5, 6 times 6. Then we just did the basic math there. 36 minus 8 to give us 28. Yeah, that's right. So now all you gotta do is do canceling. Okay? So let's take a look at what we have for canceling. Now I know most of you guys probably definitely saw right off the bat, you saw 25/30ths. Divide them both by 5. And you got 5/6. Right? Okay. The other thing, some of you saw, some of you didn't, 21/28. And you can divide those both by 7. So that'd be 3/4. Okay? Now, ooh, there's something else I didn't notice here. There's something else you can cancel that I wasn't anticipating. What else do you see that you can do canceling with? And the reason I didn't, when I wrote this problem, I just wasn't thinking about that. But take a look at 21/30. 21/30 isn't in lowest terms. You could divide those both by 3, couldn't you? Well, look at what you have now. You have 3/6. Okay? So I'm going to divide 3/6. I'm going to cut those in half. So it'd be 1/2 right there. Or I try not to plan problems out where that happens, okay? I try to plan them out to where I give you fractions that are all in lowest terms. I kind of messed up on that one. But oh well, it doesn't hurt to have that 3/6 there and then simplify it to 1/2. No problem at all with that. So we have for an answer, 5 times 1 is 5. And 4 times 2... Well, that's kind of weird. I did not plan on that at all. 5/8 for both of them, and for both of them. 5 times 1, 5 times 1, 4 times 2, 4 times 2. That was not on purpose. What a coincidence. Anyway, those are there just to give you a little bit of a taste of how to deal with the order of operations within a multi-step problem involving fractions. So, again, nothing terribly complicated, nothing that you need to really do a whole lot of editing with this video for. So, just back it up, watch these a few times, and then you can go through and, you know, use this when you're doing your problems out of your packet. I don't have any notes for this particular set of problems. You just, you know, can copy them down if you want to. Just, you know, push pause. You can go back, rewatch a video, push pause, and copy the problems down a step at a time, and until you understand it. That might be the best thing for you to do, but I'm not providing any notes for this. This is just kind of a little side thing here. So, anyway, enjoy. Thanks for watching. Have a good day.